Hello guys, so how are you all? So guys, today we are here to study a very important and very interesting topic which is known as normality. So guys, to study normality, you should understand a few more terms before studying normality. So these are number of gram equivalent. So guys, what is number of gram equivalent? You all know number of moles. So number of gram equivalent is given mass of any substance. Let's say H2SO4. You are given mass, let's say 98 gram, and divide the equivalent mass. You all know number of moles, which is defined as given mass divided by molar mass. So, but what is equivalent mass? So, equivalent mass is nothing but molar mass divided by valency factor. Here I am representing valency factor as n. So we can find n for acids, bases, salts. How we can find? I will tell you. Let's say for acids. For acids, valency factor can be find as number of replaceable H plus ions. Let's say in H2SO4 there are two replaceable H plus ions, so n is 2. In HCl here is only one H plus, so n is 1. Let's say take one more example. Let's say H3PO4. Here its structure is like this. So the H plus ions which are attached to oxygen are replaceable. So valency factor for H3PO4 is 3. Similarly for H3PO2, its structure is P double bond HOH. So here only one hydrogen is attached to oxygen, so its valency factor is 1. So in this way you can find valency factor for acids. Now we have to find valency factor for bases as well. For bases, it's very simple. Number of replaceable OH minus ions. Let's say take an example, NaOH, very basic base. So in NaOH, here is only one OH minus ion, so valency factor is 1. Let me take one more example, AlOH thrice. Here are 3 replaceable OH minus ions, so its valency factor is 3. Now let me form a salt from H2SO4 and AlOH thrice, which is Al2SO4 thrice. So for salts, valency factor can be also find very easily. It is defined as the total positive or negative charge. You can find very easily. Like Al exists in 3 plus form. So 1 Al has 3 plus charge, and here 2 Al ions. So 2 into 3. So valency factor for Al2SO4 thrice is 6. Similarly, you can also find it by SO4. SO4 has 2 minus charge, and here are 3 SO4 minus ions. So valency factor again is coming to be 6. So for salts, valency factor can be find as total positive or negative charge. Hope you have understood. So now you have understood this term, valency factor, and molar mass. You know, let's say you have to find equivalent mass of H2SO4. So for H2SO4, molar mass is 98, and valency factor we have just found, which is 2. So 98 by 2, 49. This is equivalent mass of H2SO4. So let's say for 98 gram H2SO4, I am giving you 98 gram H2SO4, and for 98 gram H2SO4 you have to find number of gram equivalent. So for 98 gram H2SO4, number of gram equivalents will be given mass 98 divided by equivalent mass. So number of gram equivalents for H2SO4 will be 2 for 98 gram. Similarly for 49 gram it would be 1. So in this way you can find number of gram equivalents. But why I have told you about number of gram equivalent before normality? Now I will tell. So normality is defined as number of gram equivalent of solute dissolved in 1 liter solution. So from here you can find a formula of normality, which is number of gram equivalent of solute divided by volume of solution in liter. Let's say you have to find the normality of, let's say 98 gram H2SO4 only in 100 ml solution. So 100 ml solution, we can write in liter also, which is 100 divided by 1000, which is 0.1 liter. So in 98 gram H2SO4 we can find number of gram equivalent, which is 2 divided by volume of solution in liter, which is 0.1, which is equal to 20 normal. So in this way we can find normality of any solution. You can prepare any solution of any normality of any solute. Here is a dilution law in normality, which is N1V1 is equal to N2V2. What is N1V1 and N2V2? I will. Let's say you are provided with a stock solution. Stock solution is nothing but a solution of higher concentration. Like you are provided with a solution of higher concentration, let's say 1 normal or 2 normal, and you have to dilute it according to your requirement. Let's say you are required only 0.1 normal solution, but you are given a solution of 1 normal. So from 1 normal solution, how can you prepare 0.1 normal solution? This can be prepared using this equation. Let's say you have to prepare 0.1 normal solution of 500 ml, and you are provided with a stock solution of 1 normal. How can you prepare? This is the main question. So let's say initial normality, this is N1, which is given to be 1 normal, and the final normality, which is 0.1 normal. This is normality in which solution you have to make, and you have to make 500 ml of this solution. But you don't know its initial volume, how much volume of 1 normal solution you will take. So you can put all these values here. So N1 is 1 normal into volume, which we have to find, N2 we have to make 0.1 normal solution. So 0.1 normal, and we have to make 500 ml of 0.1 normal solution. So from here you can calculate 50 ml of 1 normal solution is required to prepare 500 ml of 0.1 normal solution. So how can you prepare from this? You have calculated, that's very good, from the dilution law, because you require 50 ml of 1 normal solution to prepare 0.1 normal of 500 ml solution. So to prepare this in lab, let's say you take a container of 500 ml. You add 1 normal solution, 50 ml. Now you will dilute the solution by the solvent. Let's say in this case our solvent is water only. So you add distilled water and fill the mark up to 500 ml. Total you have to make 500 ml solution. So 50 ml you have added 1 normal solution, and and then 450 ml you will add water. So total you will get 500 ml solution. So in this way you can prepare 0.1 normal solution of 500 ml. The 0.1 normal solution 500 ml. Okay. So I hope so you all have understood the concept of normality and how from this dilution law you can prepare any solution of any concentration. So thank you and bye bye.